Well, hello again everybody. Now I'm sure that most of you will remember last week that we were playing with this, well, it's a Cosa 635 wannabe because it's not actually a Cosa radio. Now a few people suggested various names for this. I think I suggested Frankenstein. We also got the Frankenfurter radio, which is, well, it's very Rocky Horror, isn't it? But I think the winner of the naming this radio prize, I have to say, I think it goes to Andrew, who's come up with kind of an amalgamation of the Cosa name and Decca. So he's come up with the Cosica. So I think we're going to be referring to this radio in future episodes as the Cosica. Now, having done a little bit of a cold start video on it and proved that this thing will actually function, so I'm going to take this radio and I'm going to put it in a box for a few months until the weather gets a little bit warmer, and then we can go into the garage and we can start stripping down that old cabinet and try putting on some new veneer. Now that's not something I've done before, so I'm going to be asking you all for lots of hints and tips on how to do that, because I'm pretty rubbish at woodwork. And as I say, of course, we've got to change out all these horrible and nasty waxy capacitors and all these nasty evil hunts that are hiding under here. And this speaker's also totally crappy, so that's got to go as well. It's an 8-ohm speaker, and I had a look in the radio service information. Of course, it should have been 2.5 ohm, so I'm going to be looking for a nice big 3-ohm speaker to replace this with. But that's all going to up and coming in the future, so for now we're going to put this away and we'll see it again in a few months' time. Well, as per usual, I find myself apologising for the general state of my workshop. So you can see on this shelf here, I actually keep all my power supplies to one side of me. So I've got this old Tti Power Supply which I've had donkey's years. So if we actually switch this on, this goes up to I think this goes up to about 30 volts, okay, about 32 volts, and I think about 3 amps. Is it going to go up? Yeah, that goes up to just over 3 amps. Now, I've got another power supply which is just next to it here, which is another fairly Fandar one. So switch that on, and it roars into life. So this is my other power supply, and I think this goes up to, well, it only goes up to 20 volts, so that's a bit feeble, isn't it? But the thing about this one, it does 20 volts, and I think it goes up to 20 amps. So we've got quite a bit of current there, and of course a 20 amp power supply, I quite often use that for powering up some of my ham radio equipment when I'm doing some testing on it. But that's not quite the power supply I'm going to be looking at today, so we'll switch him off. So what we've got here is an old Heathkit power supply, and this one's specifically designed for powering up valve equipment. So this is quite useful because it's got the supplies here for the various heaters. So we've got 6.3 volts AC and I think it's 12 volts AC. So this is good for powering the filament, the heaters up on valve tubes. So that's good. And on the other side here, I think we've got the high voltage output here. So we've got an output of, I think, of up to about 400 volts. So again, this is very, very handy for testing valve gear. And this power supply is actually made by Heathkit, and I don't think it's one that I've shown you before. I've not had it very long, and of course the reason I bought it was to do a bit of a restoration video, but unfortunately I got unlucky because yeah, it just works. In fact, let's just prove that. I haven't even plugged it in. Let's just plug it in and see if it explodes. 350 volts out of this. So this is good for testing valve gear and stuff like that. This is not what we're going to look at today, although maybe it'll feature in the future, because before we use this in anger, I do want to change out some of the electrolytics and do a bit of service in it. So again, this might appear in a future video. Let me know if you want to see it. Turn him off for now. Well, you know what, I can tell by the look on your faces that some of you are feeling just a little bit underwhelmed at the size of my power supplies. You're not exactly satisfied. I'm kind of hoping that this thing will be a little bit of an improvement, because this one goes up to 30,000 volts. What could possibly go wrong? Well, just the other day I was out on a road trip with one of my friends, Andy, you know, the chap who has the American cars, and we were driving along towards Southport, and we actually called in, of all places, a garden centre. Well, apparently it used to be a garden centre, but now it just sells various kind of stuff that the tip would refuse. But they did actually have some vintage equipment there which was looking quite unloved and in a sorry state. So I actually managed to pick up this for I don't know, well, it was £10. I'm trying to read what it says on it. Does it say spares or repair or still works? Oh yeah, it does say spares or repair. So I've got no idea whether or not this will work or not, but I think we're going to have to be a little bit careful because, well, 30 kilovolt, it's not to be sniffed at. So it looks as though it's got two ranges. It's got a 5 kilovolt range and a 30 kilovolt range. And I think this is probably what they'd refer to as something like a Hipot tester. So it's used for measuring the insulation resistance of equipment in the test environment. I haven't bothered to look it up, I haven't googled it yet. Let's just have a turn it round because there is actually a maker's mark on it. I think that's an IT30, it's got a serial number. I think that says Miles Hivolt Limited. Something like Shoreham by the Sea, Sussex, England. So turning a piece of equipment over, we've got this, well, it's a veritable smorgasbord of voltage selection. We can go from anywhere between 100 volts to 250 volts in, what's that? In about 5 volt steps. God, there's some real voltage adjustment there. At the moment it's set to 240. I might actually increase that to 250 because my voltage here is quite high, but I think we'll worry about that later. And then I think tucked down here we've got one of those, oh, what do you call them? I wanted to call it a Belling Lee connector, but that's the kind of thing you have in the back of a television, isn't it? The RF connector. I forget what they call them. Them 3-pin connectors there. So just looking at the front panel, we've got quite a selection of controls and meters. So it looks like we've got a meter down here which is calibrated in microamps, and we've also got a multi-turn pot, which is a, well, very fine multi-turn pot, which is EHT, so that must be for increasing the output voltage. Just notice that on the actual voltmeter scale here, which is unusual, it's actually in kilovolts, so we're not on volts, we're on kilovolts here. So we've got one scale that goes up to 5 kilovolts, and we've got another scale that goes up to 30 kilovolts. Well, unfortunately the piece of the glass, the plastic bezel appears to be broken or missing, so hopefully that's something we can have a go at repairing. Maybe we can make a new one. And again on the front we've got this row of selector switches, so let me just read it out. That says check battery, so it seems strange that this piece of equipment would have a battery in it, but maybe the voltmeter or the controls is battery isolated. I'm not sure. We're going to have to take the cover off and have a look. We've got an on-off control here, which, well, one would assume that turns it on and off. And then we've got this selection here between, well, it isn't a selection, you can actually select both of them together. We can select either 5 kilovolt output or a 30 kilovolt. It's got some kind of a trip on it which we can reset. That's a non-latching button. And then it looks underneath as though we need to select the range for the current meter. So it either divides by 10, multiplies by 1, times by 10, times by 20. Then at the bottom here we've got something which says interlock, and I'm guessing that this is some kind of safety switch that has to be enabled before the unit will output its high voltage. Got a 0 set for the microamps. But of course the main thing that we're going to be interested in is this 5 kilovolt output socket here. And this 30 kilovolt output. That really is quite scary, isn't it, 30 kilovolt? Unfortunately, I don't know how we're going to go on about actually finding a connector for these. I certainly don't have anything that's going to fit these. I assume that these are something which are quite special, but maybe if you've used these Hipot insulation resistance testers, because a lot of you might have used these back in the factory or back in industry, you can maybe tell me where you get the connectors, or what you, at least what you call these connectors, because I think we might have to get some of them. Looks like we've got what is just some earth terminals for, well, I guess screwing or connecting your earth electrodes to. and a guard wire. I'm not exactly sure what the function of a guard is, but I assume it's some kind of safety earth. Again, I'm not exactly sure. Now again, because of the age of this, I'm also assuming that it's going to be kind of traditional transformer technology in it. Maybe it's going to be something like a television with you know, like a line output transformer or a voltage doubler or something like that. Again, not exactly sure. So it's a bit of a mystery what we've got inside here. Just feeling for some looseness. I'm not feeling any looseness yet. Maybe, I'm sure 30,000 volts might loosen me up though. Okay, still no looseness. Oh, there we go. So it looks like we've got a low voltage power supply here. Not exactly sure what we've got. Well, I think that should probably come out now. Okay, so I can see some transistor stuff going on, so it looks as though it might be comparatively modern. Okay, well I've just removed the top cover end. I've got to admit, I'm not particularly expert on these. It looks like what we've got here. I'm guessing that this is like a metal brick here. It feels as though it's got a metal brick cover on it, and I'm guessing that this is a high voltage transformer, maybe something similar to what you get in a neon sign transformer. And I think we've got this white thing on the side, which I've got to admit I expect it to feel solid, but actually just touching it, it's actually soft. It's like a block of rubber. So I'm actually guessing that maybe this module on the right hand side here, this white coloured one, I'm thinking that might be something like the voltage divider, because this has got a voltmeter on it. So I'm thinking that maybe it measures the output voltage. So I'm guessing that we've either got maybe the rectifiers installed in this block, or we've actually got the resistive divider, which is actually going to divide this 30 kilovolt down to something which the meters on the front of the panel can read. We've got some big power transistors, got a couple of big power transistors here. So again, I'm guessing that they are going to be doing some form of pulsing to this transformer. Not exactly sure, I've got to admit. Got another white box here, which I think could be a relay. Maybe that relay is switching the power onto this high voltage transformer. So just taking a look at the unit from underneath, it looks as though we've got a couple of units here, and I think that these are some form of high voltage, maybe high voltage read relays, something like that. I could be wrong, but I think they might be high voltage relays. Again, I'm just guessing that they're relays because we've got, you know, high voltage on each side of them, and then we've got what looks like some control wiring going to them. I could be completely wrong, I'm not familiar with them. So you can see these two black covers, we've got one on top of the other. Well, these are the output meters that we were looking at earlier. So let me just see, the top one, I think the top one is the voltage output meter, and the one underneath it, we've got two here. The one at the bottom is the microamps output, and they have actually got a label on them here, which looks as though that these meters must have been quite high quality back in the day, because it looks as though they've got hand calibration marks on them. I'm just going to have a look to see if I can read the label. It's a bit small, and I think it says BIFAM. Not exactly sure if that's a manufacturer of the meter, and there is some stuff written on it. It looks like there's a serial number which is W73059. I wonder if that serial number could be something like the year 73. And looking at that, it looks like it's a full-scale deflection 100 microamps. So it's a fairly sensitive meter, isn't it? And of course made in England. And just adjacent to these meters we've got 1, 2, 3, 4. We've got 4 lamp indicators, that's these things here. And then under the lamp indicators we've got the push button switches that we actually looked at earlier. And mounted just behind the controls and the dial meters we've also got this little printed circuit board, and there's really not very much on it. I can see that there's 1, 2, 3, 4, there's 4 transistors. There is what could be either an op amp, it says IC1 here, so that could be, well, I'm guessing because it says IC, it maybe is some form of digital logic, I'm not sure. You never know, that could be either an op amp or it could actually be some kind of you know, conventional logic. I can't quite make out the number on the case. We've got a potentiometer on here, which is probably for calibration, and really that's about all she wrote. So there isn't like loads of waxy capacitors on here or anything that looks particularly nasty or worrying. Of course, we've got one of these Phillips capacitors on here, but they're generally not too bad. I think maybe if we can power this up a little bit gradually, it may be okay. But I'll tell you what, let's just move this out the way for now and have a look at the actual other power supply module. So this is the power supply module that I removed earlier, and this looks as though it's a DC output that powers all the electronics. And of course on the other side of it we had this voltage selector, and we've got this 3-pin input connector here. I'm not sure if I've got anything that will fit that, so that's a little bit annoying. In many ways that looks a little bit like the connector that the old Weller soldering irons used to have on them, so it may be that I actually go and see if I can find an old Weller soldering iron floating around somewhere, because it does look as though it's about that size that the old Weller soldering irons used to have on them. So I don't think we're going to find anything very exciting under here, apart from perhaps just a power supply. So, but let's have a look. You never know. So I am actually quite well used to working with high voltage stuff, and although it might look as though I'm a little bit blasé, to be honest, I am quite careful. So we've actually got a big smoothing capacitor here. Can't actually see what the value is again on it because it's the way it's clamped in. Doesn't look as though it's particularly high voltage. I think it says 40 volts. I can also see that we've got a bridge rectifier in here, you know, one of those old-fashioned bridges, and it looks as though across the bridge rectifier we've got quite a large wire wound power resistor. So I'm guessing that that's going to be a bleed off resistor for this capacitor. We've got 10,000 microfarads at 40 volts. Well, low ESR, it's coming up as 0.04 ohms, so it's coming up as in-circuit leaky. I wonder if we can just disconnect one of these tabs on it, because maybe it'll come up then. I think we can disconnect that one. Okay, so it did take a little bit of time to come up, but it's actually come as, what's that, 11,070 microfarads at 0.04 ohms for the ESR. I'm not even sure, does my chart go up to that? So that should be 0.01. So this has come up as 0.04, so it's come up as a little bit high, hasn't it? So I've just gone ahead and I've got my benchtop power supply set to about 30 volts, and it's set to current limit at just a couple of milliamps. So I'm hoping we'll have to charge this capacitor up and see if we've got any problems. So our 10,000 microfarad capacitor, that's just charged up to about 30 volts, and as you can see it isn't drawing any current at all now, so it looks like we've got a good capacitor there. Well, as it turns out, this has got quite an unusual mains connector on it, and I think I may have said earlier that it looks a lot like the type of connector that used to be on the old Weller soldering irons. So I've just gone ahead and I found my old Magnastat iron, and these old Weller soldering irons, I'm sure most of us into electronics, we've owned these at some point in our past, and I've got to admit they're really, really good. I mean, lots of people will tell you these days that you've got to own the latest in super thermostatically controlled variable iron, but the reality is we all use these Weller soldering irons for 50 years, and they're very good. They're very good for things like valve radios and you know, heavy wiring. They're relatively high power, 45 watts, that's not to be sniffed at. But of course, the important thing today is, will this connector fit? Because I think it will. So as you can see, it is actually a 3-pin connector, and it looks about the right size, and it has got a groove cut into it, which is, you know, for indexing. So let's see if that will fit. It's actually quite a tight fit. I don't think this power supply is particularly well designed. Okay, that seems to go in. I think that is the one. Yeah, I think that is the one, but certainly it doesn't feel, it feels a bit tight because this voltage selector kind of gets in the way. Right, so we are just going to have to go ahead and unsolder this, I'm afraid. It's a shame that I don't have a spare one, but, well, the problem is I don't have a spare one, so we'll have to cut this off, I think. Well, I can't exactly tell you why, but I had an absolute nightmare trying to assemble this plug. I'd actually forgotten how horrible these were. I think the main problem was that the wires were actually just really too big for the connector, but this really does seem like a horrible connector and really not that well suited to 230 volt mains, although according to the label it is actually rated for 250 volts, but well, I think you take your life in your hands if you use them for that. For soldering irons I think they're fine, but yeah, I'm not too impressed with that. Anyway, after all that complaining and moaning, we have got it together. And you do have to kind of shoehorn this connector in because it is tight up against this voltage selector switch. So in theory now we can go ahead and reassemble this back into the chassis, and in fact that's what I think I will go ahead and do. So I think that I can just actually slide this together. Okay, I think that's gone together, and let's just put a couple of screws in to stop it flapping around in the wind. Now I did actually explain this as being a power supply, and it's probably not quite true to call it a power supply. Really what it's called, I think a lot of people call it a Hipot tester, and it's used for insulation resistance testing. So really it's basically just a big megameter, but it's still quite capable of delivering some quite nasty and you know, potentially lethal voltages. I think the current is limited, but I'm not exactly going to say it's limited to a safe level. This thing could still really be quite lethal. So let's just check we've got an earth to the chassis, because we're going to need that for sure. Yeah, so that's coming up as 0.5 ohms. Okay, so we're up to our full 230. Nothing seems to be happening. So in theory there should be a fuse in this plug. Reason being, I've actually just salvaged it from a computer power supply. It's a brand new lead still wrapped up. Probably good job I checked it, because it is a 10 amp fuse. Oh, it does look actually it does look a little bit Chinesium in flavour. Let's just check that that fuse is intact. Yep. Don't think we want a 10 amp fuse, that can go in the bin. And we'll put a 3 amp fuse in place of that. So for reasons unknown, we didn't get any action on there, did we? I'm pretty sure it wasn't powered up. I mean, I didn't even go poking around with the voltmeter. I've just got a feeling it wasn't drawing any current at all there. I think the 0.4 of an amps was really kind of nonsense. I think we've just got to pull this power supply out and maybe just investigate it a little bit closer. I wonder if it's making good contact with everything. Of course, we've got no idea whether this piece of equipment works or not. You know, it could be damaged for all we know. The transformer's blown up. I've got no idea. Yep, got it to there. Comes out the back of the mains connector. I think that goes into a fuse there. So what will happen here? The live wire comes out of this main socket on the back, goes through a fuse, and it immediately goes up to this socket on the front, and it's going to go from that socket to the front panel selector switch, I think, where the instrument will be powered on and off, or that's what I assume will happen. And then that mains power will return back. But I'm just wondering, where will it return back to? Which of these wires does it return back on? So the problem is it's all beautifully loomed up, but because it's so beautifully loomed up, it's very hard to actually trace out the wiring. I think what I'm going to do is I'm going to just reassemble it, and I'm going to try and follow the mains through live. Let's see if I can do that. So I'm going to go on the live pin of my plug. So I'm just switching it on and off. I'm just trying to find the return wire, if there is one. Well, I've been messing around with this power supply for about half an hour and I'm still having problems. Now, as you can see, this power supply, it actually has a remote mounted power on switch, so I've just gone ahead and had to trace a wiring out, but I've linked that mains connection out here just using this yellow jumper cable. So in theory I should be getting my full 230 volts up to this up to the power supply now, and I did test it earlier and I was getting it, but to actually make it a little bit easier to test, I'm actually just going to disconnect the isolation transformer. One of the annoying features about isolation transformers, of course, is Well, it's a safety feature. You can't actually use the earth as a reference anymore. So when you're doing testing, what I quite like to do is I like to clip one of my leads onto the chassis, and then I can use that as a ground reference for the live supply. But of course you can't do that when you use an isolation transformer, because you just get a misleading reading. So what I'm going to do instead of that, and I've got to admit this is slightly less safe, but maybe just a more practical way of doing it. I've disconnected the isolation transformer now. I'm actually going to plug into the normal supply, and I'm going to use a variac to actually turn the voltage down. Now, as I say, it's not such a safe way of doing it, this. Even though I've turned the voltage down, at the end of the day a variac is an auto transformer, so it's not actually a safer way of doing it. There's more of a chance of electric shock, but nevertheless I'm going to take that risk, and this is what I'm going to do. Oh, and I've tripped the power out. Well, how queer. Well, I don't know if you noticed, all my power just tripped out then, and what I'd actually done is I'd taken this power supply off the isolation transformer and I'd actually plugged it onto this variac, which is non-isolating, and the main earth leakage circuit breaker just tripped out in my consumer unit. So really what that's kind of implying is that we've got a fault to earth within this power supply. Now, most of you've seen me in the past. I'm pretty religious in doing safety tests on any old equipment that I buy. I nearly always do the insulation resistance test, and I check it for earth leakage, but for whatever reason I decided not to do it this time. I think I was just a little bit, well, just wanted to get on with it, crack on and play with this thing. And of course, in my haste, I've been bitten. So let's go and get my Claire tester out, and we'll just run that over this power supply. There is definitely something iffy about it. And now it's actually failing on insulation resistance. So as you can see, I've been playing around with this transformer, and I'm afraid to say I really can't find very much wrong with it, but I think I'll just show you what I have been doing. So here's a transformer which I've actually just been and got out of the garage. I've had this thing about 10 years, and it's been sat in the garage, in a damp garage, for about 10 years. It's not a particularly good transformer. I think I bought it from RS at some point many years ago. So what I'm going to do is I'm just going to use my megameter here to do an insulation resistance test. And the way you do that is basically all you need to do is I'm just going to put one connector on the primary windings, and I'm going to put my other connector on the secondary. And what you should be looking for is, well, the higher reading the better. So let's just let's set that off. In fact, I'll put it on 500 volts. And this reads, well, the maximum reading that this can go to is 999 megohms. So effectively that's 1 gig, isn't it? 1 gig ohm of resistance. So there is absolutely no leakage between the primary windings and the secondary windings of this transformer. So that's good. That's what I'd expect to see. And just press the test button, and that comes up. Well, I'm going to say it comes up lower. It comes up a lot lower. It's coming up as around 150 megohm, and before the other transformer was coming up 1 gig ohm. So if we just take that figure of 150 megohm of resistance, so we've got a leakage between primary and secondary, and potentially to 0 volts, because the windings on the secondary are connected to 0 volts. We've got a maximum leakage there of well, I've forgotten already. Was it 150 meg? Alright, I'm going to call it 140 megohm. So we've got the main supply voltage is 230 volts, and 230 volts across 150 megohm, call it exponential 6, and that equals 1.5 microamps. Now 1.5 microamps isn't enough to trip an earth leakage circuit breaker. So what I'm basically saying is, although there's a little bit of leakage between the primary and secondary here, it shouldn't actually be tripping the earth leakage circuit breaker in my consumer unit, but it certainly is tripping it out. It's done it 2 or 3 times now, and I can't really explain why. Well, for once I actually managed to surprise my good lady wife. She thought I'd put the dinner on, but no. Now previously you saw that I had a problem with this power supply tripping out the earth leakage circuit breaker, and I did an insulation resistance test, and actually the transformer wasn't coming up too bad. I think initially it was coming up about 150 megohms, that's what it was coming up as, which actually isn't too bad a reading. Generally that wouldn't concern me, and if you do a back of the packet calculation, That comes out at not very much, it's around 6 microamps leakage. Now it would actually be slightly higher than that because I probably should have used the peak of the mains waveform rather than the actual RMS value, but still it wouldn't have been double. It maybe would have been I don't know, 7 or 8 microamps, but it certainly wouldn't have been the 30 milliamps that it actually took to trip out my earth leakage circuit breaker in my consumer unit in my main supply. However, I've spent quite a lot of time looking at this and I really couldn't find a problem with it. So what I decided to do is put it in the oven and try to dry it out. So it's been a combination. It's about a week later. This power supply has spent a couple of hours in the oven with a temperature set at 50 degrees, and then the rest of the time it's just been sat on a hot radiator. So the initial reading was about 150 megohms. Then after a few days on the radiator it came to 240 megohm. I think I put it in the oven then for a few hours, took it out of the oven, tested it again, and then it had risen to 478 megohms. Just this morning I tested it at 500 megohms and it spent another 4 hours in the oven. So I'm just going to test it again, and I know it should come out about 800 megohms because I've just tested it before I switched the camera on. It's around 900 and, well, it keeps going. That might even get to 1 gigohm. So basically it looks like one of the problems, in fact we've now got infinity, so it looks like one of the problems that we had before is that there must have been some dampness in these transformer windings, which doesn't surprise me because where we actually got this from, it was actually stored in a greenhouse. Literally it was a big greenhouse, and it was cold and it was damp and it was wet. It's definitely absorbed moisture. Now that shouldn't have made my earth leakage trip. However, I've spent a lot of time looking at this power supply and I can't find anything else wrong with it. So what I intend to do, having dried it out a little bit, let's reassemble it and see if, let's see if it works now. Fingers crossed. Now just thinking back, the original problem I actually had with this is we couldn't actually power up the power supply. It's not that it was tripping out the earth leakage, it just couldn't get any power to it. And I've done some tracing round, and what I think the problem was is one of these pins here connects from the live mains supply, and it goes to the switch on the front of the piece of equipment and then comes back. So unless you have these links in place, the power supply won't actually power up. Now it should have worked, but I think what the problem was, some of these pins were slightly bent back. So what I did was I just got a sharp tool and I've just prised them up a little bit, and I think they weren't making a good contact, and I've also cleaned them with some switch cleaner. They shouldn't have needed it because they're gold contacts, but that's what I've gone ahead and done, and unfortunately I didn't get that on camera. So let's go ahead and reinstall the power supply, and well, hopefully this thing will work then. Okay, that's lined up. It's just a bit tricky to line those mating connectors up when it comes together. Is it going to come on or is it going to trip out the mains again? 1, 2, 3. Oh. Well, it didn't trip the mains out, but then again, nothing happened either. But I think I know why. Let's have another go. I think we need this interlock plug installed. 1, 2, 3. Oh, and we have some action. Back of the net. I think we just need to select one of the power supplies. So I guess let's select the lower voltage one first. So that says 5 kilovolts. So press that in and we get a light on. So in theory, I think all I have to do now is turn this knob here which says HT on it, and that should become live, that socket. Unfortunately, I don't know if I've got anything that we can use to test that. Oh, okay. Well, that needle's just twitched up, so I think we're on the lower scale. So just turn that. Oh, so it looks like something's working. There's 1 kilovolt. There's 2 kilovolts. 3 kilovolts. Shall we go for the whole 5? Well, in theory we should have 5 kilovolts on the output socket now. Don't think I'm going to put my finger in it to find out though. We'll just turn that down. And we also need to try to replace the glass in this meter. I'm not sure what we can do about that, but we need to do something with that before this meter gets damaged. So it looks like the 5 kilovolt range does something. Well, certainly the meter goes up, but we haven't tested the outputs. Let's just quickly try the 30 kilovolt one. If anybody knows what sort of connectors these are, please let me know, because they look as though they're something quite specialist. I certainly haven't got anything that will fit them. So I assume we just press the 30 kilovolt and we get an amber light this time. That's very pleasing, isn't it? So let's just turn the voltage up again. I can smell ozone, and I can hear that high voltage noise, which is kind of quite frightening. Put the 30 kilovolt output on again. Okay, so the dial now, well, it says 10 kilovolts on the meter here, and this is, oh shit. Okay, so yes, we've definitely got some HT on there. Well, unfortunately, I don't think we're going to be able to go over 10 kilovolts because this connector's breaking down. I think it needs an insulated plug in it. Okay, so that's 10,000 volts. So I would say that we've actually got a winner here. So I'm going to turn that off. Okay, so that's fine. So when it's actually got a mating connector in it, that connector doesn't flash over. So we need the right connector to use there. We need something that will withstand 30 kilovolts, because obviously the test setup I'm using at the moment just can't do that. Right, let's try the 5 volt range again, because that was all a little bit more sensible. So let's put my probe in here. So at the moment, this should be about 1000 volts, which it is, bang on. This should be 2 kilovolt, which again, it's bang on. These meters are actually perfectly calibrated. This should be 3000, which is 3, 5, about 5.1. But when you're talking about thousands of volts, I'm not really that concerned. So I have actually turned everything off, and I've been round it with an earthed probe, and I've made a point of trying to discharge everything that I could, trying to make this piece of equipment as safe to work on as possible. Oops. Somebody definitely has been in here before me, haven't they, because we find it isn't actually screwed together. So there's a crafty look at this meter for all you meter aficionados. Can actually see some bits of fluff floating around in there. And of course that's another problem with having the glass missing from the front of it, because if we get any kind of contamination, it can find its way into this very fine meter movement and it'll jam it up. So you really shouldn't ever run a meter without a front cover on it. Well, I think that we're actually going to need this Velman signal tracer to repair this meter. So here we go. Can you tell what it is yet? Well, I'm sure some of you have guessed what I'm going to try and do with this, and I've got to admit, I've got absolutely no idea whether or not this is going to work, but well, let's face it, it's all I've got, so it's better than nothing, isn't it? Well, I think that looks something like it, doesn't it? Yeah, we seem to have clearance between the front. Okay, I think that is going to work. So I've just gone ahead and I've tried to secure this just using some super glue, and well, the problem with super glue is it's not always that super, is it? So I've got a feeling that I might be unfortunately be stuck here for some hours. Okay, I think that might work. Stands a chance. Well, I wouldn't say that it's perfect, but actually, when all's said and done, it's not far off, and it's certainly a lot better than it was. So let's go ahead and see if we can just reassemble this thing now. Now, as we saw earlier, for some reason this didn't have any screws in it. Now, unfortunately, I don't think I am going to have any screws I can put back in it. They seem to be quite long ones. Okay, I think that's gone together. Come on. Oh, there it goes. Managed to slip that in as easily as a night out with a Barnsley girl. Well, I've got to admit, I don't think I've done such a bad job of this meter repair. It's certainly given it a new lease of life and it looks 10 times better. Now, I'm not tightening these up very much because they're going into aluminium. If you start riving on them, we're just going to strip the threads off. So I'm just nipping them up just a little bit. Fingers crossed this is the last time we have to install this power supply. So let's just hope it all goes together. Yep, I think that clicked in okay. Well, I'm not sure about you guys, but I know that I'm actually going to feel quite disappointed today if we don't actually test this 30 kilovolt output socket. And of course the problem was we don't actually have a connector that fits it. So what I've done is I've taken my 3D printer and I've actually printed my approximation of a high voltage connector. Now at the end of the day, I don't know how good it will be or if it's going to work. It'll be interesting to see what the dielectric withstanding strength is of PLA plastic. I'm not sure. I assume this would be better if it was printed in ABS or something like that, because I know that PLA can actually absorb a lot of water. However, as I said earlier, we use what we have to hand, so that's what I've done. So you can see the high voltage connector that I've constructed here, and really the main feature of it is this long protective collar. So we've got a central conductor here, which is a black thing in the middle, and I actually stripped that connector, that central connector. That's an old phono plug which I've actually pulled apart, and I've had to bend it slightly, but it seems to be a rough fit onto the pin which is installed in the high voltage power supply, the output socket pin. So it's not a perfect fit, but it's not bad. And then we've got this long collar which points forward. It's quite a deep collar, this. It's about 15 millimeters. And then we've got an outer collar. So the whole idea is we want to make the high voltage, we want to make it travel as far as possible before it can get connection onto the steel of the socket, because, well, it's not steel, it's aluminium, because what was happening before is the actual spark was jumping from the centre pin and it was jumping to the outside of the connector, and it was doing that at a relatively low voltage, around 10,000 volts. So I'm hoping we'll get a bit more out of this. So I'm sure you can also see that the wire that I'm using, it's also a high voltage rated wiring, and I think I actually bought this to wire up some neon signs previously. I've got quite a few meters of it stuck in the garage somewhere, and hopefully you can see that. It's actually got quite a thin central core, but then it's got quite a thick silicon inner jacket, and then it's got a hard, I don't know if it's PVC or something like that, it's got a hard protective outer jacket. So I'm hoping that that's going to withstand the 30 kilovolts that we're going to be playing with this afternoon. So as you can probably see, there's actually a screw thread on the actual high voltage output socket, and unfortunately I couldn't actually 3D print that when I did this just yesterday, because I was trying to make this connector quite quickly, but I think it is such a coarse thread. If I can actually figure out what that is, we do stand a chance of being able to 3D print a socket which will actually screw on. So depending on whether or not we use this generator again in the future, we may have a go at doing that. But for now, it's just a fairly tight push fit. Hopefully that'll do the job. Now I've actually just rescued this nylon cutting board because I think nylon is a pretty good insulator, although it is hydroscopic, so it's important to make sure you find something which is dry. Now I think I'm going to have to try to retain this cable a little bit better, because it's actually quite stiff and it seems to drag everything around. I've got a sticky pad which is of somewhat unknown vintage, so I don't know how sticky it will still be. Might not be that sticky at all actually. In fact, you can always tell that they're old when you can't actually get the backing off, can't you? Okay, let me stick that down there. Is that going to stick? Okay, that seems semi-sticky. So I think we're going to employ the same high voltage metering as we did last time. Okay, what could possibly go wrong with that? So I'm sorry if it appears to have gone a little bit darker. That's because my bench, I have a lot of sensitive and expensive test gear plugged into it. So what I've done is I've disconnected all that, unplugged it, and including the lamp above the bench, because it's all on the same circuit. Because we have got 30,000 volts flying around on here, and you know, don't want to damage possibly sensitive and expensive equipment. So that's why I've done that, and that's why it's gone a bit darker. So hopefully, fingers crossed, we're going to be able to switch the power on now, and yeah, fingers crossed we don't trip the mains out again, because I will be in trouble. Here we go. Oh, need to switch that on. So let me select the 30,000 volts range. And I guess all I have to do now is just start to wind the voltage up, and I guess we're going to wind it up until that plug flashes over. Maybe it won't. So we're at 2,000 volts now. There's 5,000. There's 10,000. So far so good. We're at 16,000 volts, and I can hear corona discharge from somewhere now. You know, you get that feeling when stuff is at high voltage potential. You get a bit of a crackle and a bit of an ozone smell. So we've got the smell of ozone now, and a little bit of a crackle. Sounds as though the crackling is actually coming from my cutting board here, my nylon insulator. Right, we're at 20,000 volts now. 20,000 volts now. Can you guys hear that? Can you hear anything? Getting like the odd ticking noise as something discharges. Okay, we'll keep going. It sounds as though that noise is coming from my cable. Right, I can hear quite a loud discharge now. Sounds to be coming from around that connector somewhere. Now I can also see on the current meter here, it's actually waving around. It's actually started to increase a little bit. Yeah, and in fact it's gone up quite considerably, so it does show now that we're actually getting some current leaking to earth somewhere. Not exactly sure where. I think we're nearly at the full voltage now. Okay, so we're at 30,000 volts now, and everything seems to be withstanding, but we are drawing some current now from the power supply, so we've definitely got some leakage to earth. Oops, and my plug has just started to flash over. So it wasn't perfect, was it? But we got a lot further using my high voltage plug than we did before. We got to 30,000 volts there before it flashed over. I think it's quite interesting that my high voltage probe here is actually quite sensitive, because if I just touch the nylon mat, I'm actually some way from the actual cable. It's actually giving me a reading of about 2,000 volts, but I suspect there really isn't any current there, and I'm just wondering, is that because this mat might be a little bit damp? But certainly things that you expect to be perfect insulators clearly aren't. Now as I get closer to the actual high voltage source, you can actually see, hopefully you can see on the fluke meter, the voltage is actually just going up and up and up. So I'm still a good centimetre off it now, and it's actually showing 18,000 volts. And just touching it, now we're at 25,000 volts. So now we're actually at these high voltage. I actually think that you can see the current meter. That's the current meter on the bottom that's wagging backwards and forwards. Well, I'm actually just getting close to the insulated section of the cable. I'm not even touching the outer conductor of our high voltage supply, so you can see just a leakage through the air. So it really is a very sensitive current meter we've got here. Well, you know what, I don't actually think I'm going to push my luck anymore today, because I think we've done enough. Now before I actually do finish for today, I think it's probably important that I give the obligatory safety notice. Messing about with high voltage equipment isn't a good idea. It's quite a dangerous piece of equipment, this Hipot tester. It could give you a really nasty electric shock, or in fact it could even be lethal. So it's not something that you should be messing around with. The only thing that qualifies me to mess around with equipment like this is I'm an idiot. If I mess around with it, you don't have to, and that's the advice. Don't mess with high voltages, because you can come a cropper quite quickly. It's easy to make a mistake, and you could injure or kill yourself. Well, for today, that'll do. So until next time, as always, thanks very much for watching, and I hope to see you again very soon. Until then, bye bye for now. Bye.